Chapter 2, Polynomials. The presentation contains the following topics: 2.1 Introduction to Polynomials, 2.2 Polynomials in one variable, 2.3 zeros of a polynomial, 2.4 Factorization of polynomials, 2.5 Algebraic identities, 2.6 Summary. Introduction to Polynomials, Algebraic expressions. Before diving into polynomials, it's important to recall the algebraic expressions you have previously learned. These include the basic operations: addition, subtraction, multiplication, and division of algebraic expressions. Also, remember the algebraic identities such as x plus y, squared equals x squared plus 2xy plus y squared, x minus y, squared equals x squared minus 2xy plus y squared x squared minus y squared equals x plus y times x minus y. Polynomials. A polynomial is a specific type of algebraic expression. We will study the terminology related to polynomials, the remainder theorem, factor theorem, and how these are used in the factorization of polynomials. Polynomials in one variable. Definition. A polynomial in one variable is an algebraic expression that involves only one variable with non-negative integer exponents. For example, 2x squared plus 3x plus 4 is a polynomial in x, 3y cubed plus 5y is a polynomial in y. Terms and coefficients. A polynomial is made up of terms. Each term consists of a coefficient and a variable raised to an exponent. Example, in the polynomial 4x cubed minus 3x squared plus 2x minus 5, the terms are 4x cubed, negative 3x squared, 2x, and negative 5. The coefficients are 4, negative 3, 2, and negative 5. Degree and types of polynomials. Degree of a polynomial. The degree of a polynomial is the highest exponent of the variable in the polynomial. For example, the degree of 5x to the power of 4 minus 3x squared plus 2x minus 7 is 4. Types of polynomials by number of terms. Monomial, a polynomial with one term, e.g. 7x. Binomial, a polynomial with two terms, e.g. x squared minus 4. Trinomial, a polynomial with three terms, e.g. x squared plus 3x plus 2. Types of polynomials by degree. Linear polynomial, degree 1, e.g. 2x plus 3. Quadratic polynomial, degree 2, e.g. x squared plus 2x plus 1. Cubic polynomial, degree 3, e.g. x cubed minus 3x plus 2. Example 1. Finding the degree. Problem. Find the degree of each of the polynomials given below. 1. X to the power of 5 minus x to the power of 4 plus 3, 2. 2 minus y squared minus y cubed plus 2y to the power of 8. 3. 2. Solution. 1. The highest power of the variable is 5. So, the degree of the polynomial is 5. 2. The highest power of the variable is 8. So, the degree of the polynomial is 8. 3. The only term here is 2, which can be written as 2x to the power of 0. So the exponent of x is 0. Therefore, the degree of the polynomial is 0. Zeros of a polynomial. Definition. A zero of a polynomial p of x is a value of x for which p of x equals 0. Example. For p of x equals x squared minus 4, the zeros are x equals 2 and x equals negative 2 because p of 2 equals 0 and p of negative 2 equals 0. Properties. A linear polynomial has exactly one zero. A polynomial can have more than one zero. The zero of a non-zero constant polynomial does not exist. Example 2. Value of a polynomial. Problem. Find the value of each of the following polynomials at the indicated value of variables. 1 p of x equals 5x squared minus 3x plus 7 at x equals 1. Solution. P of 1 equals 5 times 1 squared minus 3 times 1 plus 7, which equals 9. 2. Q of y equals 3y cubed minus 4y plus the square root of 11 at y equals 2. Solution. Q of 2 equals 3 times 2 cubed minus 4 times 2 plus the square root of 11, which equals 16 plus the square root of 11. 3 p of t equals 4t to the power of 4, plus 5t cubed minus t squared plus 6 at t equals a. Solution: p of equals 4a to the power of 4, plus 5a cubed minus a squared plus 6. In general, we say that a zero of a polynomial p of x is a number c, such that p of c equals 0. Finding zeros of a linear polynomial. Example 3. Check whether negative 2 and 2 are zeros of the polynomial x plus 2. Solution: let p of x equal x plus 2. Then p of 2 equals 2 plus 2 equals 4, and p of negative 2 equals negative 2 plus 2 equals 0. Therefore, negative 2 is a zero of the polynomial, but 2 is not. Example 4. Find a zero of the polynomial p of x equals 2x plus 1. Solution: solving the equation p of x equals 0 gives 2x plus 1 equals 0, which means x equals negative 1 divided by 2. For any linear polynomial p of x equals x plus b, the only zero is x equals negative b divided by a. Example 5. Verifying zeros. Problem: verify whether 2 and 0 are zeros of the polynomial x squared minus 2x. Solution: let p of x equal x squared minus 2x. P of 2 equals 2 squared minus 4, which is 4 minus 4, equaling 0. P of 0 equals 0 minus 0, which is 0. Hence, 2 and 0 are both zeros of the polynomial x squared minus 2x. Observations: 1. A zero of a polynomial need not be 0. 2. 0 may be a zero of a polynomial. 3. Every linear polynomial has one and only one zero. 4. A polynomial can have more than one zero. Factorization of polynomials. Factor theorem. If p of a equals 0, then x minus a is a factor of p of x. Conversely, if x minus a is a factor of p of x, then p of a equals 0. Factorization by splitting the middle term. This method is used for quadratic polynomials of the form x squared plus bx plus c. We split the middle term, bx, into two terms whose product is ac. Example: factorize x squared plus 5x plus 6 into x plus 2 times x plus 3. Example 6. Using the factor theorem. Problem: examine whether x plus 2 is a factor of x cubed plus 3x squared plus 5x plus 6 and of 2x plus 4. Solution: the zero of x plus 2 is negative 2. Let p of x equal x cubed plus 3x squared plus 5x plus 6. We find the value of p of negative 2, which equals 0. By the factor theorem, x plus 2 is a factor. Let s of x equal 2x plus 4. The value of s of negative 2 is 0. So x plus 2 is also a factor of 2x plus 4. Example 7. Finding the value of k. Problem: find the value of k if x minus 1 is a factor of 4x cubed plus 3x squared minus 4x plus k. Solution: as x minus 1 is a factor of p of x, then p of 1 must be equal to 0. P of 1 equals 4 times 1 cubed plus 3 times 1 squared minus 4 times 1 plus k. This gives the equation 4 plus 3 minus 4 plus k equals 0. Solving for k, we get k equals negative 3. Example 8. Factorizing a quadratic. Problem: factorize 6x squared plus 17x plus 5 by splitting the middle term and by using the factor theorem. Solution 1. Splitting method. We need two numbers p and q, such that p plus q equals 17 and p multiplied by q equals 30. The numbers are 2 and 15. The expression factors to 3x plus 1 times 2x plus 5. Solution 2. Factor theorem. We test possible rational zeros. We find that p of negative 1 divided by 3 equals 0 and p of negative 5 divided by 2 equals 0. This means x plus 1/3 and x plus 5/2 are factors. The full factorization simplifies to 3x plus 1 times 2x plus 5. Example 9. Factorizing a quadratic with factor theorem. Problem: factorize y squared minus 5y plus 6 by using the factor theorem. Solution. Let p of y equal y squared minus 5y plus 6. We test the factors of the constant term 6. We find p of 2 equals 0, so y minus 2 is a factor. We also find p of 3 equals 0, so y minus 3 is a factor. Therefore, y squared minus 5y plus 6 equals y minus 2 times y minus 3. Example 10. Factorizing a cubic polynomial problem. Factorize x cubed minus 23x squared plus 142x minus 120. Solution. Let p of x be the polynomial. We test the factors of the constant term, negative 120. By trial, we find that p of 1 equals 0. So x minus 1 is a factor. Dividing the polynomial by x minus 1 gives the quadratic x squared minus 22x plus 120. We factor this quadratic by splitting the middle term, which gives x minus 12 times x minus 10. Therefore, the complete factorization is x minus 1 times x minus 10 times x minus 12. Algebraic identities. This slide lists key algebraic identities. Identity I, x plus y, squared equals x squared plus 2xy plus y squared. Identity 2, x minus y, squared equals x squared minus 2xy plus y squared. Identity 3, x squared minus y squared equals x plus y times x minus y. Identity 4, x plus a times x plus b equals x squared plus a plus b. X plus of identity v, x plus y plus z, squared equals x superscript 2 plus y superscript 2 plus z superscript 2 plus 2xy plus 2yz plus 2zx. Identity 6, x plus y, cubed equals x superscript 3 plus y superscript 3 plus 3xy, x plus y. Identity 7, x minus y, cubed equals x superscript 3, y superscript 3, 3xy, x, y. Identity 8, x superscript 3 plus y superscript 3 plus z superscript 3, 3xyz equals x plus y plus z times x superscript 2 plus y superscript 2 plus z superscript 2, xy, yz, zx. Using identities, example 12. Evaluate 105 multiplied by 106 without direct multiplication. Solution. This can be written as 100 plus 5 times 100 plus 6. Using identity 4, this equals 100 squared plus 5 plus 6 times 100 plus 5 times 6, which is 11,130. Example 13. Factorize 49a squared plus 70a plus 25b squared. Solution. This expression matches the form x superscript 2 plus 2xy plus y superscript 2. Using identity I, it factors to 7a plus 5b squared. More examples with identities. Example 14. Write 3a plus 4b plus 5c squared in expanded form. Solution. Using identity 5, this expands to 9a superscript 2 plus 16b superscript 2 plus 25c superscript 2 plus 24a plus 40bc plus 30ac. Example 15. Expand. For a minus 2b minus 3c squared. Solution. Using identity v, it expands to 16a superscript 2 plus 4b superscript 2 plus 9c superscript 2 minus 16a plus 12bc minus 24ac. Factorizing with identities, example 16. Factorize 4x squared plus y squared plus z squared minus 4xy minus 2yz plus 4xz. Solution. This expression matches the expanded form of identity v and factors to 2x minus y plus z squared. The slide also shows the derivation for the identity for x plus y cubed. Expanding cubes, example 18. Evaluate 104 cubed and 999 cubed using identities. 1. 104 cubed. This is 100 plus 4 cubed, which expands to 1,124,864. 2. 999 cubed. This is 1,000 minus 1 cubed, which expands to 997,002,999. Example 19. Factorize 8x cubed plus 27 y cubed plus 36x squared y plus 54xy squared. Solution. This expression matches the expanded form of x plus y cubed and factors to 2x plus 3y cubed. Example 20. Factorizing with identity 8. Problem. Factorize 8x cubed plus y cubed plus 27z cubed minus 18xyz. Solution. This expression can be rewritten as 2x superscript 3 plus y superscript 3 plus 3z superscript 3 2x y 3z. Using identity 8, this factors to 2x plus y plus 3z times 4x superscript 2 plus y superscript 2 plus 9z superscript 2 minus 2xy minus 3yz minus 6xz. Summary. This slide provides a comprehensive summary of the chapter, including definitions for monomial, binomial, trinomial, linear, quadratic, and cubic polynomials. The definition of a zero of a polynomial. The factor theorem x minus is a factor of p of x if p of equals 0. A list of the key algebraic identities covered. Thank you for learning with us.